Hello, everyone. Thank you for making it so far and staying with us, supporting us. I know it's been a long 2 days, but thank you. Thank you for being here before the closing keynote. This has been an awesome conference. I know everyone agrees on this. My name is Lara. I'm a mobile developer and Flutter GD based in Berlin.
My name is Miguel, and I'm a freelance consultant specialized in Flutter. I'm also based in Berlin.
Today we are going to talk about accessibility, how to make our apps accessible and easier to use to everyone, to all kinds of audiences.
And if you want to download the slides already and follow with us, because maybe you cannot see the screen or something, if you're sitting in the front, you can go to our Twitter account and you can open the slides already there.
Yeah, if everything went well, it should be there.
Yeah, either on your account or my account.
Yeah.
All right, let's go.
Yeah, so everyone, when we talk about accessibility, everyone has a different idea of what accessibility is. The classic definition is the design of products to be used by people with disabilities. According to different sources, 15% of the world's population has some type of disability. People with disabilities depend on apps and services that support accessibility so they can communicate, learn, and work. By making your apps more accessible, you are also reaching more users. But there's also another concept which is called the universal design, which is products that are designed so they can be used by the widest majority of people. And that's precisely what we are going to be talking today. There are two ways of helping. One way is with assistive technology, and that means that you can create a new device that will help someone to perform a task. Let's say a switchboard with 1, 2, 3 switches. Like here on the screen, you see there's a board with a couple of switches. Then the user can press to make actions. The braille keyboards, I'm sure that many of you have seen. But we are not covering this in this talk. Another way of helping is with adaptive technology. This means to adapt existing technology to enable a person to perform a task. And that is what we are going to focus today. Learn to adapt your Flutter applications.
To do that, and for this talk, we will take an existing Flutter app, and then we will evaluate the current status regarding accessibility, and then we will fix it. The app we used is a clean yet complex Flutter application. This is a project that I worked for a few months, and that now is open source. So it was the perfect example to do that. And as you can see, it's a messaging app, which is also a common use case. On the left, what you have is a drawer with some options, user settings, channel selection. It's very similar to Slack. And on the center, we have a messaging area where you can read messages, write messages, and also send attachments. On the right, there's a slide in with some details. And also as well, you can find the link to the project here. At the bottom is an open source project. You can go to GitHub and check it. We will be evaluating the accessibility of the app in respect to 4 different types of disability. We took the most common ones, but more of them exist. We will focus on the motor disability, vision, neurodiversity, and also hearing impairment. We will talk about what challenges people with these disabilities have and how we can help them. We will assess our application, collect the issues we find, and fix them later. To do a first preliminary test of the app, we're going to be using the accessibility scanner. This is an Android application that you can download that will suggest accessibility improvements to your app. It works by scanning the application and detecting any possible improvement targets that you have. Some of the things that it will detect are small click areas, low contrast areas, missing labels, and so on. So let's run this.
When we run the accessibility scanner on one of the app screens, this is what we got. We are going to go into detail later on each of these cases and fix them. But I want you to see that in this simple screen, where we have a couple of messages, we have already a lot of work to do. We also use some accessibility options from iOS and Android, and we will be talking about them later, but be aware that when using simulators or emulators, the amount of options that you have on accessibility options is way smaller. So we recommend you to always use a real device when possible.
Right. Let's start with movement disabilities, which take the large majority of affected users. A motor disability when using software means that a user may have an interaction, may have a limitation interacting physically with your app. It depending on the level of disability, they may face different challenges. For example, a user may require large click areas, but also maybe the user requires a special hardware because they are not being able to tap on the screen. And in the most severe cases, the user may need to use just voice-activated software. How can we help? If you are developing games, you can enable a way to set difficulty, to make the game easier for people who has this type of disability, and also to provide a mode that can pause the game so they can play at their time. You need to be sure that keyboard or switch navigation works, and provide the user with the options of using your application, either using this keyword or this switch access that we saw at the beginning. As well, you can try to enable navigation via voice. And of course, build the app in a way that you have adaptive UI components that will get larger if the user enables the option in the accessibility settings on the phone. And also enable things like auto-completion and help with the text input. One of the issues that the accessibility scanner found was small click areas. The accessibility scanner is highlighting here the view that has the issue. In this case, this is a username which is clickable, and that will open a user profile later. The problem is that this click area is too small. This is reported as a touch target issue, and as you can see here at the bottom of the screenshot. This is one of the things that we're going to fix later. Yeah. We try to use also keyboard navigation, and I want to show you a video how it works. To try to navigate through items using taps and a keyboard. And as you can see, it's almost impossible to know what's going on because it's hard to see which items are being selected, which clickable items, and to see where you are. You can see in the screen also the taps that we are doing. Impossible. We weren't able to accomplish our task. To open, we were just trying to open the user profile here. It was impossible. So we used switch access to test the application. And this is called switch access on Android, and it's called switch control on iOS. This scans the app and highlights columns and rows of items, allowing the user to select things by tapping on this switch. So we try it again with the switch access. And you can see with the switch access, it goes selecting different items on the screen, and then you can type and you can select them. You can click on the switch access. So we were able to open the user profile, then to navigate back, then to open the chat area, and also to start writing a message even so. To summarize, the issues that we found when checking accessibility for motor disability were small touch targets, and also that the keyboard navigation was not so good, but instead the switch navigation was the right way to do this, and we found that it was working well by default with Flutter.
The second disability type we are going to be evaluating is vision issues. According to the World Health Organization, there are 4 levels of visual impairments. From more severe to less severe, we have blindness, severe visual impairment, moderate visual impairment, and mild impairment. But also keep in mind that being legally blind does not mean that you are fully blind, because there are different levels of vision. It's estimated that 2.2 billion of people have vision impairments or blindness. Think about that, 2.2 billion of people. So how can we help here? We should support large font sizes, support screen readers, we can have high contrast content as well. Vision disability affects lots of people, as I said, but there are many users out there that can benefit as well of this, by these improvements, even though they are not technically disabled. For example, myself, I use a larger font size settings in my phone because I find that modern devices have very small fonts, and by supporting large font sizes for people with disabilities, you are also helping me. We are going to be talking about colorblindness specifically later, but first let's take a look at different options, things that we can do. So one of the settings that we can find on both Android and iOS is font scaling. This allows to make the text larger, and the good news is that text widget supported by default. That's awesome. The thing is, however, that RichText widget does not. So what we did is to check our application with the largest font size on Android first to see how it changes. And you see there are differences in both screenshots on the screen. Not too much, but still is something. On iOS, the change was way bigger. Here we have a screenshot. On the second screenshot is the largest font setting available. And you can see that the text can become massive. We recommend you always to test the font sizes with iOS. And use an iOS simulator if you can. This is one of the options that is available. On Android, there's another option called display size. This makes UI elements on the screen larger, icons, containers, etc. When we check our application, we see that it's not well supported on Flutter. It seems like it's not supported at all. You can see maybe the icons on the status bars and the clock are a bit larger, but the rest of what is our application remains the same. iOS has an option called text bold in order to increase contrast for visually impaired users. And as you can see on both screenshots, it seems to be well supported on Flutter, just by enabling the setting. Another option is magnify. And this is an option that is available on both iOS and Android. This allows users to zoom into your application by doing a double tap on the screen. So keep in mind that if you are implementing something in your application that requires some gestures, that tapping several times, this can also conflict with this magnify option. I think, yeah, this one is only available on physical devices on iOS, as we were saying before.
Yeah, and that's why we have an ugly picture here instead of screenshot, because
yeah.
It only works on devices.
And then we also discovered that there's a lot of unsupported options on iOS. For example, the button called button shapes, which underlines buttons to make clear that they are clickable. An option to display labels on actionable items like switch boxes. And this display either a 1 or 0, I think, to say whether they are enabled or not. One option was also reducing transparency, another increasing contrast. They were not working. We didn't see any noticeable changes. And so we suspect that they are not supported. But we will see later that still we can do something.
Colorblindness is also a type of vision disability where there's a decrease on the ability to see color or differentiate between colors. It affects the 8% of male population and 0.5% of women. It doesn't mean that you are only able to see in black and white, but it means that you may not be able to differentiate between two different colors. So how can you help? Well, don't use just color, but instead add icons to explain messages and add text also as well. Do not rely only on color to show an error or something like this. And if that's your only option is to use color, at least give the option to change them in your settings.
There was, when we were playing Fortnite,
yeah.
I remember that we used to, and there, when you do, I think it was doing the setup, or you can go to the settings, and there was an option to change the colors,
yeah.
Adjust them to your vision, and I found that awesome.
And there is a colorblind test there in the settings.
Yeah, yeah.
Yes. So on Android, we can check how colors are going to look like by using Simulate Color Space. This is an option that is deep into the developer settings. You can select there monochrome or all the other 3 colorblind options, and then you can go back into your app and see if you can still use it or it's just a gray thing that you cannot understand anything. So with the accessibility scanner, we detected missing item labels. For example, in this menu item, it doesn't have what is called a semantic label here that screen readers can read out loud. And another type of vision issue that we found with Accessibility Scanner was low text contrast. Here it says in this text field for writing a message that the text contrast is too low, and we're going to see how we can improve that later. People with severe vision disabilities use what is called the Android Talkback, and it's also called VoiceOver on iOS, which is a software that reads out loud what's on the screen. And when using it, it works like this. You tap on something and then it reads back. For example, if we tap on the center of the screen, what it reads back by default now is "Dogs are the best," which is the title that you see on the top of the scaffold. If you tap on a menu button on the top, the 2 that are on the top, it says unlabeled button. And when you tap on a chat item, it reads the time and it reads the message, but it doesn't read the user name who is saying that. So we can do things way nicer here. But also as well, when you're using Talkback, you don't just use Talkback alone. You use Talkback with gestures. And with gestures, it means that the user is going to be swiping through the screen to select between things. And this works like the switch navigation that we saw before, plus Talkback. So if you want to test it properly, use this option, Talkback plus gestures, and go through your app. We also evaluated the app using iPad to see the differences with VoiceOver and also the gesture navigation. And in fact, there are some differences here. The results are similar, but we get some different reads. For example, the buttons are not registered as buttons, but instead as images. It says, for example, if you tap the menu button, it says image, possibly menu. And another thing is that the avatars that you see on the screen, they are, Talkback says puzzles, because VoiceOver, yes. VoiceOver says puzzles because VoiceOver can describe images using image recognition software and try to guess what it was there. So in this case, thinks there is a puzzle, okay, a puzzle. We have found different issues here. When using Talkback, we are missing labels everywhere. And also the text descriptions are missing, like for example, the author of the message was not there. The text input also has low text contrast. And we have found that the display size from Android, this setting that we tried, it's not working. And for iOS, we found also a lot of settings that were not supported for accessibility. We're going to see what we can do here to improve that.
The third type of disability that we are going to look at is neurodiversity, which refers to the diversity of the human brain. We want to include it here also as well in our accessibility study. Neurodiversity covers different disadvantages that users can face. That could be from focusing problems to learning difficulties. I'm sure that you have heard before about disorders like autism, ADHD, dyslexia, different problems. So what can we do? There are many, many things, and we focus on some specific examples. We can, for starters, use a minimalist design. which means focus on the task that you have at hand and you eliminate all the distractions around. Narration is also something that can help users keep focus with your content. For example, if you have a learning application, by including both audio and text, so they can read along. This can help a lot to your users to absorb your content. Spell checking plays an important role as well because there are users that have writing difficulties. Remember its settings and passwords. Seems like a very small thing, but it's very important for those people that have memory issues. So being able to paste passwords is crucial. So be sure, please, that pasting passwords work. Also, guide the users through your application by showing some hints, but don't overwhelm them. When using text fields in general, we can help neurodiverse users by facilitating typing. In Flutter, autocorrection is enabled by default, but sentence capitalization is not. Sentence capitalization means that when the user starts writing, the first character of the word will be lowercase or uppercase if you capitalize.
Enable capitalization.
You know what I mean.
Yeah.
And that's also something that will be happening each time that you write a new sentence. We can help users by enabling that. And that's going to be a quick fix that we will show later. I work at Blinkist, and this is a screenshot of the app that we have, where in this application you can read the key points of a book. You can play the audio to listen to it, but the user can also read and play the audio at the same time. And I realized that I need to do both at the same time because otherwise I don't focus. So, you know, what we were saying, if you provide narration to your users along with the text, you help them focus. This helps a lot to distracted minds, and I'm sure I'm not the only one, and also will help people with learning difficulties. So around neurodiversity in this application that we took as an example, we only found a tiny fix that we need to do, which is capitalization. It's a tiny fix, but it's important as well.
And finally, also hearing loss. Hearing loss is another disability that affects the 1% of population. And a way to measure how severe it is by performing a test on measuring the hearing threshold of the person, either by air or also by bone conduction, and find at which decibel level they can't hear anymore. Also as well, another test is repeating words in a word recognition test to see how many words that person can understand correctly. How can we help them? Well, if you're providing any type of multimedia content, you have to provide closed captioning. And because there's even regulations regarding this, and this is mandatory also in some countries. You can also give visual signals, and again here the game Fortnite, right? There's a setting that allows you to see indicated on the screen where the noise of steps are coming from. But if you have an app and you use notifications, you have some kind of internal notification that is making some sound, well, you should have an option also there to add vibration. And this is something you can solve in Flutter also as well. Not just sound. But on Android, there's also a really cool feature which is called live captioning. This allows users to read live-generated subtitles from any kind of audio content playing. For example, here there is a podcast and it's running with live captioning. And the subtitles appear on the center of the screen, and you can even move these subtitles up and down. This is an Android 10 only feature, and if you're creating some sort of audio player, podcast player, etc., be sure that this works with it. In any case, so in our case, we didn't find any fixable issues in our app, but we wanted to talk about it anyways.
Yeah. So now, after all the talk and introduction and evaluating the app, we are gonna finally fix the issues. So let's recap and see what do we have to do. So we want to fix the touch targets because they were too small. Fix the sentence capitalization. Fix also the low text contrast that we have in the messaging area. Also check the dynamic font scaling and see how it behaves. And fix all the missing semantics. So the first one is touch target. So the issue here, as Miguel was explaining before, is that the touch target is too small. This happens because the Inkwell widget that we have here for the clickable area, to give us the clickable area, is constrained to the child region, and which in this case is a text widget that contains the username. This does not satisfy the minimum interactive dimension. In Flutter, we have a constant called kMininteractive dimension, which defines the minimum interacting dimension that any region should have according to the material design guidelines. This means 48 pixels in Android and 44 on iOS. The 44 is what is defined in the Cupertino module, but you will find that all the material widgets follow the 48 guideline, regardless of the platform, I mean. Yeah. So to fix this, what we use is ConstrainedBox widget. This will allow us to set a minimum size. So we add the constant, we pass the constant mean interactive dimension to set the size. And so this is gonna force the widget to have at least the minimum interactive dimension that we set. This is basically what material widgets are doing. For example, the icon button. Now, we have another problem, which is that the text is larger in height, so the UI looks a bit different. So we have to fix that. To do that, what we use is the align widget. We remove existing paddings that we have, and we add a bit of padding to the avatar. And now we have the same UI as before. It looks the same, but we have a larger click area for the user.
Now we're going to fix the text fields capitalization and the autocorrect options. We're going to see what we have here. By enabling text capitalization in text fields, we can help users write better messages. This is disabled by default. It's set to text capitalization none. Setting it to sentences will help users to write better sentences. It's a quick win. After a dot, so a space, and then it goes a capital letter, and also when you start a text. But always think of the use case, because not all text fields require capitalization. Like a username, for example, you don't want to have capitalization there. Two more improvements available here are autocorrection and suggestions. These two properties are enabled by default, but think twice before disabling them. The thing is that on iOS, autocorrection is the only one that is being used. On Android, it requires both autocorrection and for spell checking, and also to enable suggestions to suggest new words from the keyboard. So there's a big difference. Let's talk also about the low contrast that we had in the text field. In the app, the field for writing messages is a text field, typical widget, with an input decorator that has a custom style that we have created, which was provided by our designers. One thing we can do first is to compare the value that we're using here to the value that the Flutter framework provides, to see, well, maybe we're doing something wrong here by using the custom one. So to check which is the default color from Flutter, from hints, we looked at the input decorator widget class. Here we saw that it uses the disabled color defined in the theme data, which by default is color black 38. Okay, so we have these two colors here. Here we have the two colors side by side to compare them. And I guess you cannot see the difference here in the projector. They look very similar. They are not exactly the same, but they are very similar. And in fact, if you use the screen to see it, you will see that the black 38 is actually a bit lighter than the one that we were using. So switching back to the default color, it didn't work. It didn't fix the problem we had. We need to do something else. Before, we were talking about this high contrast setting that is available on iOS. This is exposed through the high contrast property in MediaQuery. And you can find that in the Flutter framework. It's a Boolean that returns if the user has the accessibility option for high contrast enabled or not. We can use this Boolean to apply a higher contrast to our theme and our application. But unfortunately, when we started using this, we saw that it didn't really work because this value was always false, no matter which setting we had. So we opened an issue on Flutter, and then we started exploring the source code, and it turns out that it was hard-coded to false, so it was to do. And we have opened a pull request fixing this. But the thing is that because this is a breaking change, and well, it has been open for 1 month, waiting for approval.
So when it's a breaking change, you have to follow a long process and a lot of discussions. So it's still open and didn't make it to the talk, which is sad.
Design document and then wait until it's approved and everything.
But hopefully it will be soon.
But it's an easy fix.
Yeah, I mean, it was supposed to be an easy fix. Okay, now let's fix the text scaling. As I said before, RichText was, no, I didn't say that, sorry. RichText is good for text spans, like, for example, highlighting links to URLs, usernames, etc. But RichText does not scale based on the text scaling that the user sets on their settings. But the text widget will read the textScaleFactor. And so the thing is that if you're using RichText, you basically have to pass this, the textScaleFactor from the MediaQuery by yourself. Like, I think we do it on the text, in the snippet. Mm-hmm. And finally, let's fix all those semantics labels that are missing. As we saw before, many items on the screen were highlighted because they didn't have labels. These labels are what the screen readers will use to read what's on the screen. To fix this, we are gonna add proper descriptions. What's content descriptions maybe sounds familiar to Android developers. So we will add this to all the UI elements. And for doing it, we are gonna use the semantics widget. A semantics widget will explain what a piece of UI is, explains whether the element is enabled or not, and will know if it's an input or a read-only field. To help you debug all your labels, Flutter gives you the awesomest widget. I think it's the awesomest one, which is called Semantics Debugger. This visualizes what the semantics for the child are. You can use it to wrap your widgets, and in this example, we wrap the whole scaffold. The Semantics Debugger widget is drawing with different colors each of the semantics regions, writes also in text what is gonna be read by the screen readers, so this will help you debugging and fixing your application.
Without having to go into talkback.
Yes. That's something I don't think exists in Android. I've never seen that.
No, in native Android apps?
No,
in native code, I never seen that.
I just fell in love with that widget. So the first button we are gonna fix is the menu button. We wrap the button with the semantics widget, which will annotate what the widget contains, or the description, the meaning of the widget is. And so to do that, we add a label, in this case, menu. We also set the property button to true, so we let the screen readers know that this is a button and not something else. And now the screen reader will read it as menu button. We do the same with the send button, which is disabled by default. And this information, this piece of information, the button is disabled, is very important for the user. They need to know whether it's actionable or not. So to fix this, in this case, we do the same. We wrap the widget with the semantics widget. We add the label, in this case send. We set the button to true. And then we also use another property from the semantics widget, which is called enabled, where we pass a Boolean that will basically inform whether the button is enabled or not. So on the slides you see on the top, the button as disabled and the second image as enabled, sorry. And you see the differences on what it will read. In the case of disabled, talkback will say send button disabled, and the other case will say send button. So when we use the talkback, again, the screen reader, when you tap on the center of the screen, as Miguel was explaining before, the screen readers are reading like dogs are the best, only the title. We need to give more information on what we have on the screen, right? We need to give some more context to our users. So in this case, we wrap the scaffold with the semantics widgets again. We add another label, in this case, chat screen, something. And after that, the screen readers will read chat screen, dogs are the best. Now, we also need to fix the messages. We can do complex labels, combining values, for example, the name, timestamps and stuff. And for example, here on the snippet, what we do is to create a string that contains the name, the body of the message, the timestamp. So the talkback will read it as message from Coco, good morning everyone, smiley face at 1844. But it will continue reading, and it will continue reading afterwards, 1844, good morning everyone, blah, blah, blah. The thing is that we added a label, and the screen reader is reading the label, and then also the text on the widget. We need to ignore the text on the widget because we already have the label, the more complex label. Can we do that? We can. We can use the exclude semantics widget, so we can remove widgets in our messages, for example. Here we will use the exclude semantics widget to remove the text widget from the semantics, leaving only the label. And this way, the screen readers will only read the label. The semantics are a powerful tool. You can use it also to improve, you can use it for improving the accessibility in your app, but you can also use it for your widget tests. Because when you do widget tests, you need a way to find what's being displayed on the screen. So with the semantics, you can use the label that you define as any other testing matches to find the widget. And you can do that by using by semantics label to find the widget when you're testing. This can even be easier to use than other testing matches. So we recommend you to do it, because by having semantics, you're using people. You are helping. You are helping people, but you are also able to test and have a robust application.
Okay, we are done. So let's check back our to-do list here. If we check again the list, we have now completed most of the tasks that we have proposed. We fixed the touch targets that were too small. Also, we had to change the layout a little bit to accommodate for larger widgets. We also enabled the text capitalization, which was a quick win. Regarding the text contrast of the text field, as we saw by the design system of Flutter, it kind of expects that the hint text is going to be lighter, so harder to read, and also the solution that we tried with the high contrast setting on iOS wasn't doing anything. So this problem was definitely not solved. We checked the dynamic font scaling and saw that RichText widgets does not support it by default. So we added the textScaleFactor value to it. On semantics, we fixed both the missing labels on buttons, and as well we improved the way the text descriptions are provided within the app. And we added some tests also to verify everything. If we run the accessibility scanner again, we see that we could get rid of all the warnings except the one for the hint text. So if you want to improve the accessibility of your app, you can run the following steps. First, run accessibility scanner on Android. That's the quickest way to get a review of your application with all the actionable items. Then, check the larger scale font on iOS, because you saw that it has the higher setting here, and you can see if anything is broken. Semantics is a great way to make testing easier. So even if you don't want to focus on accessibility on your app, you can use it as a matcher for your widgets and to improve your tests. Finally, don't forget to embrace the text field built-in improvements. Try to make the life of your users as easy as possible, no matter if they have a disability or not.
With this talk, we hope that you have seen that by doing small changes in your applications, you can help many, many, many people out there. And also remember, please remember that being inclusive is the right thing to do.
I hope you have learned today lots of things about accessibility and how to get the best of it using Flutter. This is us, and this is our dog Lily, and thanks a lot for listening.